Hey, what up people, welcome to my channel. My name is Fred. So real quick, today we're going to be looking at how to construct a normal and a tangent to the following special curves. So we're going to be learning how to construct a tangent to an ellipse. We're going to also look at cycloid, parabola, and involute. So this video is going to focus mainly on how to construct a normal and a tangent to all of these special curves. So now I have already constructed the ellipse, the cycloid, the involute, and parabola. So what I'm just going to do now is to show you how to construct tangent to these four special curves. Now, to see videos on how to construct an ellipse, cycloid, parabola, and involute, I've already uploaded videos on these special curves and many more, so you can go check them out before proceeding to learning how to draw the tangent. So let us start. So we'll start with an ellipse. Now, if you notice, I have two ellipses here. All right, so this one is the auxiliary circle method, or if you like, you can call it the concentric circle method, while this one is the intersecting arc or focal point method. Okay, so in order for you to construct a tangent to an ellipse, this is what you do. Now, every ellipse has foci, f1, f2. That's the foci of the ellipse. Okay, now you will be given instruction on how to locate the points on the ellipse. Let me zoom this in a little bit so you would see it clearly. Okay, so you will be given instruction on how to locate the point on the ellipse. Take, for example, you might be instructed that construct a tangent to a point on the ellipse, okay, on the top right. Take, for example, let's say 50 millimeter from the center. So this is the top right. Okay, so what they meant by that statement is this. So you are going to measure, just a minute. All right, so you're going to measure 50 from the center. All right, so this is 50. All right, so the perpendicular distance from this point, 50. All right, now remember the question said top right. So get your pair of, your set square. All right, align it with this horizontal line. So support with your ruler. Okay, and adjust to the point where you had 50. That's it there. Can you see 50? So where it intersects, this set square now intersects this ellipse. That's the point P. All right, so we're going to locate the point. That's the point P. So this is the point P. So let's call it P. All right, so how do you construct a tangent? Now, it could be any point on the ellipse. The same method applies. All right, so now the first thing you do is to join that point. Okay, after locating the point, you join it to the foci. Okay, the focus of the ellipse. You know, an ellipse has two focus, or two foci if you like. Now connect this point P to F2 with a thin line, and connect this point P to F1. So that's the first step. Now the next thing to do is, now before I proceed, let me tell you how to locate the foci of an ellipse. So to locate the foci of an ellipse, you needle on the center of the ellipse, stretch half the major axis. So this is it, half the major axis. So with this half, needle on C and cut. See that? So you cut to get F1 here, and you do the same thing here. You cut to get F2. So that's how to locate the foci. Now I'm explaining this because hadn't been you used this method, you know, the foci, the foci are not visible here. You understand? So you use the same method, needle on the center, stretch half of the what? Major axis, like this. Okay, sorry. Needle on the center, stretch half. Alright, so you needle here, that's the minor axis. Cut, make an arc there as well. So this becomes what? F1 and F2. Alright, so let's continue with this. So after drawing these lines, what you do next is to, now this line will form an angle, both lines, they will form an angle here. So what you do next is to bisect the angle. So how do you go about that? You needle on this point here where you have P. Alright, stretch any radius of your choice, draw an arc like this. The arc is going to intersect both lines. So needle on this point of intersection here. Alright, stretch a reasonable radius that is more than half of the arc. Alright, make an arc here with same radius you needle here, cut the arc. Alright, now connect this point of intersection with P. So this line you're drawing now is the normal. So this line is the normal. This is the normal. Alright, so the next thing is to draw the tangent. Very simple. Now needle on this point P. Alright, stretch any radius of your choice. Alright, make an arc on this side, make an arc on the other side. If you like, you can draw even an arc, a straight arc that will connect to this one. Do you understand? But all you need is just these 2 points. Now stretch, needle here, stretch more than half of this arc, or more than half of this line. Okay, I'm referring to from this point of intersection to this other point of intersection. Stretch more than half. Okay, so bisect this line. So let me call it line 1. Let me call it XY. Okay, point X, point Y is a line. So XY is a line. Needle here on Y, stretch more than XY, half of XY. Draw an arc up there, arc on the bottom with same radius. Do not alter it. Needle on X now. Cut this arc at this point and call this. Alright, now draw a line to connect both points of intersection through the point P. Do not miss. Alright, and draw a thick line, not a thin line, thick line. So this is the tangent. This line here is the tangent, while this line here is the normal. So this is how to construct a tangent and a normal to an ellipse. So you could do the same thing here. So let me quickly locate another point on this ellipse. So now the question says construct a tangent to a point bottom left. Okay, let's say bottom left corner of the ellipse, distance 30 millimeters from the center. So what you do is you measure 30. Sorry, let me use the other ruler. So you measure 30 from the center. So this is 30. All right, but it's bottom left. Don't forget bottom left corner. All right, so I'm going to locate that point on the bottom left of the ellipse. So remember, this is my 30 here from the center. So there we have it. That's my 30. Okay, but this is the point. So it's the point on the ellipse, the circumference of the ellipse. So that's it there. So that's my point P. So what do you do next? Join P. Now you knew how I got F1 and F2, right? Let me repeat that again. You needle on the center, stretch half of the what? This is the major axis and this is the minor axis. So you stretch half of the major axis, which is this. All right. Okay, with this half, you needle either here, this point here, or this point here, whichever one that applies. You needle here, so you cut this major axis at this point. With same radius, you cut the major axis at this point, so you get your F1 and F2. That gives you F1 and F2. So now join this point to F1 with a thin line. Join this point to F2 with a thin line. Bisect this angle. So stretch any radius of your choice. Needle here. Draw an arc. Needle here. Stretch more than half of the arc. That's it. And draw the arc there and cut the arc. Alright. Then connect this point of intersection to P. Okay, and that is your normal. Extend it, extend the line out. So this line is the what? Is the normal. That's the normal. Now, how do we draw the tangent? You know what to do. Stretch any radius of your choice again, or you may as well use the same radius you use here, whichever one that applies. Just go ahead. Okay, now let me stretch any radius of my choice. So this time around, let me draw the full arc. So that's it. But my point of focus is where it intersects this line at this point and where it intersects this line at this point. So needle on this point, stretch more than half of the line. Okay, because we're actually bisecting this line. Once again, let me call it XY. XY. We're actually bisecting line XY. So draw an arc there, an arc here with same radius, don't alter it. Needle on X. Sorry about that. Cut this arc and cut this. Okay, so we have this point of intersection and this point of intersection. So connect both points of intersections through the center, the point P, and that gives you your what? Your tangent. Think thick lines. So this is your tangent. All right. So next is cycloid. All right. So okay, for a cycloid, once again you'll be given the what? The location. You'll be directed on how to locate the point you are to draw the tangent on. Okay. Now, for example, you can be asked to locate the point P, maybe for example 150 mm from the center of the circle. All right. From the center of the circle, 150 mm. So let's measure 150 mm. That's 15 cm. So this is the 0 here, and this is what? 15. That's 150. So that's it there. All right. I want to locate the point P. I'm not done yet. So with my set square, you can use any set square of your choice. Or in order for me to be exact, I already got a point. Don't forget. I've already gotten the point. So I will align my ruler with a horizontal line here. Okay, and place this ruler on top. So I will adjust it to where I measured 150. All right. So this is the point on top. So that's it. So this is the point P, where I'm to draw what? The tangent. Now, so how do you go about it? Very simple. Now, stretch the radius. Stretch the radius of the circle. All right. So this is it. So if the circle is 40, you stretch 40. If the circle is 30, you stretch 30, and so on. So this is the radius of the circle. All right. So now with this radius, needle on the point P. Okay, and cut the center line. This center line. Once again, if you want to learn how to construct a cycloid, I have uploaded videos on that. You can go check them out. So needle on this center line and cut the center. On the point P, and cut the center line with an arc. All right. I hope that's clear. Don't cut this side. No. Cut the center line at that point. At that point. All right. So let's call this point here S. This point. Now transfer a perpendicular line to this point X. So align your set square with this line. All right. Support with your ruler. all right, and adjust to this point and drop a perpendicular from here down. All right, let's call this point here Y. So take note of this point. All right, another way you can do that is you could needle here, stretch a little bit more than this line, draw an arc like this. All right, stretch a radius. Now this gives you a line, this arc. All right, so needle on this point, right, stretch more than half of the line, draw an arc there, needle here, draw an arc there, and connect this point straight up here. So it's the same thing, you still get this point. All right, so this is the point I'm looking for, Y. So those are the two ways. I just decided to use this one so that whichever one that is convenient. All right, so let us proceed. The next thing is, after locating this point Y here, all right, connect this point Y to P and extend out. This line you are drawing now is called the normal. This line is the normal. So this is the normal. Now let us construct the tangent. Now with any radius of your choice, needle on the point P, stretch any radius of your choice, draw an arc. You can choose to cut this side and this other side, or you can choose to draw the complete arc. It's the same thing. Now it forms a line. Let me call the line 1, 2. So bisect line 1, 2. You needle on 2, stretch more than half of what? Line 1, 2. Draw an arc here, draw an arc on the bottom with same radius. Do not alter it. You needle here, cut this arc. Sorry, I'll have to go and extend that arc again and cut this arc. All right, sorry, let me extend this arc again. It wasn't long enough. Okay, so that's it. Now both are intersecting at this point and this point, so you're going to connect both points of intersection through P. So through the point P, all right, and draw a thick line. Now this line, this thick line is your what? Your tangent. So this is how to construct a tangent and a normal. To remember, normals are always what? 90 degrees. A tangent and a normal to what? A cycloid. This is how to go about it. All right, the next thing we're going to be talking about now is a parabola. How to construct a normal and a tangent to a parabola. Okay, so for a parabola, it is very, very simple. All right, now take note of this span. This is the span, and this span is always perpendicular to the directrix. All right, so once again, you'll be given instruction or direction on how to directions on how to locate the point P. So let's assume the point P is somewhere here already located. Remember, you'll be given direction on how to locate it. It could be any point here on the what? On the parabola. So let us say these are points. Okay, let's locate it here. These are point P. All right. Okay, so it's very, very simple. So the first thing you do is you are going to transfer a line perpendicular to this span. This is the span. Okay, so align your set square with. Now once again, if you want to learn how to construct a parabola, I've already uploaded video on that. So if you watch that video, you will know how it came about, all of these lines. So align your set square with this horizontal line and transfer a line to the point P that you have located and draw it. Okay, it should be perpendicular to this span. So draw the line. All right, so that's it. I hope that's clear. All right, so what you do next is, you see the point, the focus here, F, you will connect it to P and extend it. So join F, the focus, to the point P and extend out with a thin line. I hope that's clear. All right, so now this line, now let me call this point Q. All right, let me call that point Q, and let me call this point R. Okay, small letter R. All right, let me zoom in a little bit so you could see what's going on. All right, now you see this angle. Now let me call this point X. Oh, okay, we already have it as P. All right, so you see this angle QPR. This angle, you would bisect it. So stretch any radius of your choice. Needle on this point P. All right. Draw an arc, cutting PQ and PR, okay, at both points. So bisect this angle. Needle here, stretch more than half the arc. Draw an arc here. Draw an arc here. Needle here. Okay, sorry, this arc is not needed. We are bisecting an angle. Sorry about that. So forget about this. That was a mistake. Okay, so I've taken it off. Now let me do that again. All right, so like I said, you needle here and you draw this arc. Needle here, stretch more than half of the arc. You draw this arc with same radius. Needle here and draw this arc. All right, so you're going to connect this point with this point of intersection. So this, if you draw this line, that's the tangent. So if you connect this point with P, with the point P, is the tangent. So draw a thick line all at once. So this line is the tangent. All right. Now what about the normal? Very simple. Needle on the point P. Stretch any radius of your choice. All right. Any radius of your choice. Draw an arc on the tangent. On the tangent. Focus on the tangent. All right. So needle on this point of intersection with the tangent. Stretch more than half of this line. Draw an arc on top with same radius. Do not alter it. Needle on this point on the tangent, not the parabola. All right. The tangent and cut with same radius. So join this point P with this point of intersection, and that is your what? Your normal. So this is your normal. All right. Now let us choose another location. Okay, maybe at the bottom. Okay, let's say somewhere. Okay, let me choose another point. Okay, somewhere here. So let me call this point. Now you have been asked to construct a tangent to this point W. I'm just changing location so you get used to both drawing it at the top and at the bottom. All right. So what did I say you should do first? First of all, you transfer a line. So come over here. Transfer this horizontal line here to the point W. Draw this. Okay. Then connect F to the point W and extend it out to the point W and extend out. I hope that's clear. Okay, so what are you going to do? Let me call this T. Okay. All right. And let me call this O. I don't think we have O here already, so O. So this is TWO. So you're going to bisect angle TWO. Is that clear? So needle here on W. Needle on this point W. Stretch a radius of your choice. Draw an arc to cut both. Needle here. Stretch more than half of the arc. Draw an arc. Needle here. Draw an arc. So they will intersect at this point. So what do? You join this point with what? W. Connect it with W and draw a thick line at once. Okay, so that's the tangent. Now, how do you draw the normal? The same thing. Needle on W, stretch any radius of your choice. Okay. Cut the tangent at both points, or simply draw an arc to cut the tangent on this point and at this point. You needle here, stretch more than half of that line. Okay, make an arc here. You needle here, cut the arc. Right, I hope you saw that. Cut the arc. Then you connect it to W, the point of intersection. And this is your what? Your normal. Very simple. Now, the last one we'll be talking about is how to construct a normal and a tangent to an involute. Okay, so the last one we're going to be looking at is the involute. All right. So once again, you will locate the point P. You will be given a instruction on how to locate the point. So let's say the point is somewhere here. So call it P. All right. Very, very simple. Now, after locating the point, the next thing you do is, you see the center of the involute. This is the involute of a circle, by the way, and I've already uploaded videos on this. You can go check it out to learn how to draw an involute. All right. Now, connect the point P to the center of the circle with a thin line. So, connect this. All right. So after drawing that, now let's call this center here. Let me call it A. All right. So we are going to bisect line AP. Bisect line AP. So you needle here on P, stretch more than half of the line. Okay. Stretch more than half of the line. Draw an arc here. Draw an arc here. With same radius, do not alter it. Needle on A, center of the circle. Cut the arc at that point and cut the arc at this point. So you have this point here and this point here. Connect them with a thin line. So that gives you the center of the line. You know, to bisect a line is to divide it into two equal parts. So now with this, needle on this center here, this point of intersection. Please, not this line, no. PA and the perpendicular bisector. So here. All right. Stretch to either A or P. Stretch to either A or P. In other words, if it is touching A, if it is touching A, it must also touch what? P. Can you see that? So draw an arc, not through this side, no, but through this other side. Is that clear? Not this way, but this way. So from A, draw an arc all the way to touch P. Or if you like, just draw an arc to cut the circle at this point. You mustn't necessarily draw it to P. But this is just for illustration purpose, so you would know how the arc is drawn. But our point of focus is where this arc is cutting this circle, this point here. Can you see that? Where this arc is cutting the circle. So now, after drawing this arc, where it cuts the circle, all right, this point, connect it to P and extend out. So connect this point to P and extend it out like this to P and extend. Now this line you have drawn is called the normal. The normal. This is the normal. So to draw the tangent is no longer difficult. Needle on P. Stretch any radius of your choice. Draw an arc here. Hold on, let me tighten this a little bit. All right. So needle on P. Stretch radius of your choice. So just draw an arc. Sorry, there was a distraction. Okay, let's continue. So you needle here, like I said. You draw an arc to cut this line that you've drawn. So at these 2 points, so let me call it point XY, right? You're going to bisect line XY. So you needle on Y, stretch more than what? Half of the line XY. Draw an arc on top. Draw an arc here. Needle on X, the point of intersection. Cut this arc and cut this arc. So you have 2 points here. All right, so connect both points through the point P. All right, and draw a thick line, and this line is what? The tangent, while this is the normal. All right, so that's how to draw tangent to all special curves: ellipse, cycloid, parabola, and involute. I'm going to be uploading more videos on special curves, and if you haven't subscribed to this channel, I implore you to do so. And also do not forget to hit the like button. The like button, very important. Hit the like button. Thanks for watching. I'll come your way again. Do have a nice day.